to Sunex. Today I want to talk about the custom lens development process. A lot of our discussions start with the customer about if you have an off-the-shelf lens that maybe gets close or meets entirely the requirements of the application. We by now have so many designs online that this is actually often the case, or the customer is even prepared to make a couple of trade-offs just to be able to go with a lens that already exists in terms of lead time or potentially required investment for a custom design. Before we go all the way to a custom design, there's also a choice potentially to scale or build off an existing lens design, right? We have lenses in this size, we have lenses just in this size, and there's a lot of them in between. So quite often we can build off a certain lens performance and maybe scale it to a particular sensor size, which brings an advantage with it because the actual design is already tested and proven, so the overall performance and expected performance is kind of known. But assume there's nothing that we can build off of. So custom design is the only choice. And there's a couple of steps that are true for any lens and custom lens design independent of the application or industry. So the first step is typically that we take in the customer requirements. We ask a couple of clarifying questions because we always try to understand more than what was actually said. So your temperature range, your application environment, all those things are very important from the beginning to really understand what design choices we can actually make. Then our design team is taking this input, creating a custom design, does a couple of internal iterations, and then we're kind of seeking already the first customer feedback, because in this entire development process, having a constant dialogue and getting constant feedback from the customer side, from the customer's own laboratories or maybe field tests is very, very important in helping us and guide us in optimizing this lens design. But the first step is typically the design review. And this is purely done on simulation and nominal data, and we compare the requirements to what the lens can actually achieve in its nominal design. Depending the case, we discuss potential improvements that we suggest, or maybe trade-offs where we maybe have to go a little bit longer in the barrel length to achieve a certain performance, because in the end in physics everything is interconnected. So it would be great if we all could just check off a wish list, but quite often we have to balance out performance within each other, but maybe also performance and cost. But when this phase is kind of completed, we're actually moving forward often and build the first prototypes. And what our team is doing internally is design validation is the first thing. Once we get the first parts back and we build the first lenses, right? Remember, this is the first of its kind, right? It never has been built before. So our engineers are taking really a deep dive into the performance and every single parameter of the lens and comparing it to the nominal design, just to make sure that what we actually build is delivering on what we promised. There might be some differences in the actual performance values, right? For instance, based on the manufacturing process and process tolerances, you will see certain parameters are changing, for instance, MTF, but others are fairly stable, like, for instance, field of view, EFL, F number. Those are very, very similar, if not exact, to what was discussed in the nominal design. We're going through the prototypes. We have sent them maybe to the customer. The customer did some initial tests and confirmed the great performance. Then we're actually moving forward and really potentially tooling up when we have spherical elements in there and start building A samples. And there's a certain amount of samples that we take in this phase to do an FAI, a first article inspection report. Again, a lot of parameters will be tested, quite often decided over together with the customer which parameters are important beyond the ones that we're interested in, simply from a lens performance perspective. And the difference between the design validation, the DV, and the FAI report is that the FAI report also accounts for some process tolerancing already and variance potential, because you're not only looking at one or two lenses, you maybe take 10 or 20 lenses depending, again, what we discussed and agreed on with the customer, and you see certain variation and variance across 10, 20, 30 random samples taken out of a pre-production line. Again, those samples go to the customer is doing their own measurements, ideally already first field tests on the camera level, compares it to our data and to their requirements, and again, this dialogue defines if maybe a filter needs to be optimized or other things need to be considered. Ideally, the barrel, the optimal components are already getting close to their final stage at this point in time. And then we're just, depending on the customer and application, we're just moving through B and C sample phases until we're reaching mass production. Depending quite often on the industry and application, along the way we then have other test points where, for instance, do a full reliability testing with high temperature, high humidity test, impact testing, high temperature testing, environmental testing for certain chemicals or gases, again, very much depending on the customer, the application, and the industry, all the way through until we reach a full day production run, statistical deviation over the production run, and then we get into the production part approval process, and then hopefully we build a lens and ship that lens in very high volumes to our customers. Again, one thing that I want to emphasize is the dialogue together with the customer, very, very important to get this feedback continuously throughout the design process to really understand on what parameters we need to iterate on. Thank you very much.